Good morning, everybody, and thank you for taking the time to join this TED Talks on Process Event Analytics, which is our solution all aimed at optimizing DCS alarm management. As Dom said, I'm Steve Leach. I head the DCS technology portfolio for Siemens Digital Industries in Great Britain and Ireland. And joining me today, we've got Andres Kapler from our chemical vertical market, and where Andres is responsible for a number of things, including technology and digitalization, and this includes the solution that we're talking to you about today. So just to elaborate a little bit more on the agenda, so what I'll do, I'll quickly introduce you to the asset and performance monitoring app suite, of which Process Event Analytics is one of the solutions that sit in that suite. We'll then focus more on the topic of today's session, which is around alarm management, what is sitting behind it in terms of legislation and drivers, and ultimately how the Process Event Analytics solution can help you with this issue. We'll then finish the session with a live demo of the solution, which Andreas will take you through, and we'll also have the opportunity for questions and answers. And this will probably all take around 45 minutes or so. So to position where we're at, the asset and process performance suite is part of our MindSphere cloud-based solution geared towards the process industries. The underlying premise of this is really all about using existing data and contextualizing it into actionable information that's some form of positive impact on operations and maintenance. So the suite provides the option to provide added value to a process plant, utilizing the latest technologies and the potential for the software as a service business model. And the suite itself has been developed over the last few years with direct input from our installed base across the world, and it's split into 5 areas when you include the Process Event Analytics topic. So just very quickly to go through those. Control performance analytics. This is a solution that's all focused around control loops and applying big data analysis to historical data. Basically, the output of that is providing you with transparency on your operations, and it provides recommendations on how the control loops can be adopted to run in the most optimum state. We then have Somatic PCS My Expert, which as an aside, we do have a session on that coming up in a couple of weeks. So I'll share you the details of that. But basically, this is connecting together cloud-based information related to the lifecycle health and service activities of our DCS portfolio, and displaying it in a clear, intuitive way to aid maintenance and operations. We have the valve monitoring solution, which sits in there, which kind of does exactly what it says on the tin. It's monitoring the valve controller. It's taking information that is there already within that intelligent device, and it's contextualizing it in a different way. So an example of this could be for use of maintenance, where you may have a regime where you annually maintain your valves. Well, utilizing this approach, you can look at doing that on a as needed basis and prioritizing the valves that need that information, that need that maintenance activity first. And this is using the data that is in the valve controller, displaying it in a different way for you to then respond to. So this is a real opportunity to save both time and money. And then the final app that we have sat in this suite is the Predictive Analytics app, which is quite a complex app using artificial intelligence to increase the effectiveness of a plant. So an example of this, it was used with a customer overseas in a turbine control application, and the model-based analytics that sit behind this identified an issue with the turbine and flagged it through the app. That same issue wasn't recognized in the form of an alarm in the DCS for 2 weeks. So in that time, a lot could have gone seriously wrong with that turbine. But this approach, using the latest kind of data analysis and predictive analysis techniques, meant that there was an opportunity to stop something from happening before it caused failure of equipment and ultimately downtime and cost. So that was a quick fly through of where our app sits in our overall suite approach and our MindSphere approach for the process industries. So if we focus on today's session and today's topic a little bit more, I want to kind of start it off with a bit of a statement. So what if you would not actively manage your alarm system or use new technologies to create data transparency? What might happen? So some of the answers, I'm sure there's many answers here, but some of the answers and impact run along the lines of, do you actually know the workload and do you understand the workload of your operators? What are they having to do to just keep that plant running that is not necessarily value added? So the impact of that could be that you have a large dissatisfied group of staff and potential kind of high turnover from an employee perspective because of the stress and everything of the situation. It could be that operating personnel miss critical events and activities as a result of that high alarm load, and this is often the case in many process plants. Ultimately, the impact of that is it affects product quality and availability of your plant, and neither of those two things are things that you wanna be going through. And then finally, how can the benefits of kind of a digitalization-based approach or new technologies be clear to you if you're putting a lot of manual effort into an alarm management system, for example? It's very often the case that is the way that these things are done, and new technology isn't being adopted to kind of augment and supplement those approaches. So if we think a little bit more now about what process event analytics is all about, and the fundamental of it is about providing transparency into your alarm system, which then ultimately provide the opportunity to prevent loss of production and also hopefully reduce workload for the operators and get the operators concentrating on what they're there to do. But we know typically that a plant manager is already analysing the alarm system, and there could be many different reasons for that, including it could be purely carried out in order to have compliance with international standards that are applicable to your business. It could be to ensure that a plant is operating within the constraints of its insurance policy, for example. But more and more it's done in order to minimize operating errors and to reduce the workload on the plant operator. But the underlying aspect to this is to ensure that unexpected plant shutdowns do not happen. Unfortunately, we've seen in the past what not paying attention to the alarm management process can cause. And in the UK, back in 1994, there was the incident at the Buncefield refinery, which resulted in 26 members of the personnel on site being injured. It caused material damage of around £48 million, and this was caused by an explosion at the refinery and then the subsequent fires. Afterwards, there was analysis of the control system, and fundamentally it showed that a large number of poorly prioritized alarms were pending, and this was one of the real things that had a significant influence on what happened in terms of that incident. Basically, 11 minutes before the explosion, the operating team of 2 people had to recognize and acknowledge 275 alarms and act accordingly in that time. That basically meant that a new alarm was triggered every 5 seconds for the operator. And that's not going to be possible for anybody to handle that. So we have done quite a lot of work on this, and we've gone out globally to ask our customers, what does their alarm management process currently look like? And unfortunately, quite a lot of people have come back and said it's highly manual. We're doing it, but it's highly manual. It's typically based on some form of Excel report that's done once a month, and on average, it's taken about a day's worth of work time to create the report. It's obviously very time consuming, but it's also a lot of wasted time and wasted cost. So the added value of process event analytics is really around the ability to being able to get automated transparency based on international standards on your alarm system. It's about identification of improvement approaches. As I said, the international standard norms are there as a default, and you have automated analytics that are there to help and support you as you move through that alarm management lifecycle. If we think about the layers of protection in a typical process plant, again, this is internationally standardized typically and divided into 6 levels. So if we start kind of from the bottom and move upwards, really the focus area of the bottom 2 aspects are all about profitable production. And this should be where as much as possible of this is automated. We know that that's not always possible. Control loops, for example, are very often not optimized and automated to the best of their capability. So basically, every unexpected situation in the plant requires operator intervention, and that's a typical task of an operator. We know that computers are really fast in processing data, but they don't have the experience and knowledge to handle unexpected situations based on that experience currently. Maybe in the future that there will be intelligence to do this. So therefore, the task of the operator is to ensure normal production and keep it within a profitable range. The aim of all the other protection levels is to protect the plant and its investments, environment, and the lives in which the event, and the lives in the event of an emergency situation. Therefore, it's really critical to design the alarm system as efficiently and as easy to use as possible for the operator. Back in 1999, the first standards applicable for alarm management in the industry was published, EEMUA 191, which those of you that know me well often know that I get EEMUA 201 and 191 mixed up. So I'm pretty pleased that I got it right there. But it took another 10 years until we were talking about alarm management as a continuous life cycle. And you can see it here based on the IEC 62682 standard, which was first edition in 2014. And this is the fundamental of an alarm management process and how it can be developed and maintained throughout the entire life cycle. We don't have lots of greenfield opportunities in the UK, but if you did, I think it's quite a lot easier to define that alarm philosophy. Basically, in these steps, you would define things like roles and responsibilities, alarm prioritization, what it's going to look like, etc. But we're typically in a brownfield situation here in the UK. So if you're having to add kind of this approach to your existing system, if it's not there to the limit to the extent that it could be, or if things have changed, for example, I don't know, your site has gone from a lower tier coma site to a higher tier, upper tier coma site, for example, and then your requirements around alarm management change accordingly. So a lot of this relies on the as-is documentation. So it's all about thinking about the kind of the identification and the rationalization of the alarms. It's about taking it through detailed analysis, so things like HAZOPs and the LOPA studies, and these are really the key sources of information. But then once potential alarms have been identified, they must be evaluated. What happens if the alarm is ignored? Are there recommendations for the operator? What are the possible causes of the alarm? The result of these should not only be auditable in documentation, but everybody should be aware of the relevance and importance of them. And it's really important that the responsible personnel are trained accordingly. So the detailed design and implementation phase deals with the parameterization of the alarms into the process control system. So within PCS 7, there are a number of tools that can help you there, the advanced process library templates, things like loop and alarm functionality, the message filter, all of these things, which will then help you to implement the planned alarm process. Of course, operations and maintenance need to have appropriate access to all the information as well. So it needs those guys need to be able to consult the documents for the identification and rationalization phase so they can understand the decision making. And any feedback that you get from this group of people is absolutely key in being able to continuously improve the alarm management process. So really where process event analytics fits in with all of this, it's about relieving the manual work in the areas of monitoring and assessment. And it identifies optimization potential. And also using a tool like PEA will help to prove your continuous work on an alarm management lifecycle in the event of you being audited. So we think about a typical user sat there with the plant alarm system, the operator. Scientific research has shown that if a plant operator receives more than 6 messages within 10 minutes, they're overloaded. We can't focus on things if they're coming too quickly, and ultimately this kind of thing, it leads to much higher effort in terms of operation, and also unfortunately leads to mistakes. This is why the values that have been incorporated in the standard are so important. If we think about it, imagine you're driving along in your car and you've got a heads-up display and it tells you every single time you do something in your car, you have changed gear successfully. The temperature is the right, the oil temperature is correct, the tires are at the right level, etc., etc. You wouldn't want to see all of this. It would fundamentally distract you from driving your car. That's why it's kind of done by exception. So why should this not be the case from a process plant perspective? So we think about the amount of things that actually could be going on in terms of the operator and what they need to do. Is there some old alarms that are no longer needed, but they're still active, they're still distracting? Is there a it's like it's not a flattering alarm, it should say chattering alarm, so apologies for that. I don't know what a flattering alarm is, but is it a chattering alarm? So it keeps coming and going for some reason because, I don't know, a level switch is faulty or something like that. Think about an alarm flood. Think about all of these things that could be happening to the operator, and ultimately you're increasing the risk of production loss, low product quality, potentially increased wear and tear to the mechanical assets out there, and ultimately failure of operation. So what if you could do that differently? And here is where process event analytics comes in. So as I said before, we know computers are brilliant at handling large amounts of data and evaluating them based on rules. So we can take advantage of these rules and combine them with the operator's knowledge. Wrong click. Ultimately, we then get a lot more transparency based on the international norms and standards. We can much more quickly identify, analyze, and classify unwanted events, unwanted warnings, and ultimately alarms, so that it can be really focused on getting rid of those as part of the alarm management lifecycle process. And ultimately, we want to be able to enable improvement in decisions that then ultimately make an impact into operations. So just before we go into the demo, really through the regular analysis and evaluation of a message system, as well as from living from a process of improving it, you significantly enhance your plant operation process. The ethos of what process event analytics is all about is about supporting you to get better and faster results for your continuous evaluation. And the results of this are optimization of the message system, quick identification of recurring events, and optimization through the automation of problem solving of recurring events. And finally, it gets you in a great place to be able to provide proof of the process that you are following when it comes to audit time. So with that, I'd like to hand over to Andreas, and he will take us through a brief demo of what the platform can do for you. So over to you, Andreas.
Thanks, Steve. I assume you can see my screen, right?
Yes, we can. Yeah.
Good. Well, thanks a lot. And also thank you for that example with the refinery. I guess it was a very vivid one. 275 alarms in 11 minutes. It's a really challenging task. Unfortunately, this is not a once-in-a-lifetime example, and it can also happen to companies that are leaders in safety, which demonstrates basically the need for a continuous alarm management process with a life cycle according to IEC 62682. A concrete example for that one is a plant in Bell, West Virginia, United States, where basically 3 serious incidents occurred over a time period of 33 hours, which lead to the release of some chemicals. And also during this incident, one of the employees died. The Chemical Safety and Hazard Investigation Boards, or in short, CSB, has started the investigations on what happened at that day. And the result were that there are certain kind of deficiencies in the plant's management systems, which lead to these 3 accidents. One of the identified areas was, among others, the alarm management system. And that's exactly where the alarm management, where Process Event Analytics can help you. Process Event Analytics is a software as a service application hosted on MindSphere. Every user gets his username and password, and he can see then, after keying that information in, the landing page. All the applications which are activated for the user can be found on this page. For Process Event Analytics, you will find here the PA Cockpit. You'll find PA configuration and the possibility to upload the collected alarm data for analysis. Within that PA configuration tile, you can configure general settings. For instance, those are things like you can create your shift, how many operators are working on the shift, and also you can define the limit values for your evaluations according to the event performance, which are in line of ISA 18.2 and EEMUA 191 3rd edition. In addition, you can also configure here the message priorities and message types of your system, which would allow that Process Event Analytics can also be configured for other systems other than only PCS 7. The Process Event Analytics Cockpit provides a granular evaluation of the performance of your alarm system. This evaluation is all based on IEC and ISA standards and the recommendations according to EEMUA 191 3rd edition. Here on the top, you can see the selected time range, August 22nd to September 22nd, and the overall system performance of this demo system was rated as reactive. If you click on the info button on the below right, you get additional informations. We see here that this is a combination, the result is a combination of the performance in the normal state and in the overloaded state. Following by the recommendations of international standards, the number of messages in each of the scenarios are considered and the overall performance level is being calculated. The same calculation as shown here for the overall system is possible for the individual sub-areas and can be selected, which enables you to identify the areas with the most urgent need for optimization. By clicking on a sub-area or by clicking on the entire system, you will receive then a detailed analysis of your reporting system for the selected time period. This includes a trend view here in the first view, which shows the point with the highest load of your alarm system. And on the right navigation, you will find, in addition, some other categories like the top 10 sources, event floods, event chains, operator changes, event type distribution, and the event priority distribution. With the watch list here on top, you can configure and individually check custom list of alarm sources. This basically is essential for the various phases of all the plant lifecycle during commissioning, but also for the continuous improvement of your alarm system. Therefore, Process Event Analytics supports you essentially in the step monitoring and assessment, as before shown from Steve, in that kind of alarm management lifecycle according to IEC 62682. Many of you know probably the alarm hit list as one of the out-of-the-box feature of PCS7. In Process Event Analytics, you get in addition the top 10 sources. This enables you to view the alarms in context of the source, and the reporting or the kind of message behavior of each message is characterized. For all of the characterization here left shown, there's also a recommendation provided, which would give you the chance to optimize the event occurrences. In this concrete example, we can see that there are actually to this alarm source many alarms associated, and there would have been probably at the end of the hit list. With this result, though, you can identify directly the alarm source, and you can then think and check the operating philosophy of the equipment, and by this you can reduce the workload of the operating personnel by optimizing accordingly. A typical question in determining also the cause of a high workload is the question about what type of messages are there. Is the workload caused by alarms, warnings, operating requests, or control system messages? Process Event Analytics offers for every kind of analytics a graphical representation for each analysis. For the alarm distribution, you can just check on the right the event type distribution, and you get a detailed overview of the last month. What is the alarm load? And by selecting an individual day, you receive the detailed daily history of the event type distribution. One of the highlights of Process Event Analytics is the recognition of alarm chains. With newly patented algorithms, we enable a quick analysis by the users. This enables basically the optimization potential immediately after commissioning and throughout the entire operating phase of a plant. Because we all know that basically after an engineering phase of a plant, the loop check takes place, which in most cases is also the completion of the engineering project. Now the plant at that point is taken over by the operating personnel, and if necessary, also supported by the engineering project during the startup of a plant. However, at this point, dependencies on alarms and the operating physiology of equipment may become known, which not have been considered during the design implementation phase. This would lead, if not being fixed, to an additional burden on the operating personnel. Process Event Analytics can recognize chains and represents them with useful information, including their relevance, their significance, occurrence, and the change length of the chain is immediately visible. Also, by selecting a chain, the time distribution can be displayed. The chain shown begins here with a message which is not really meaningful. Afterward, we can see there is a message about preparing cleaning and an alarm that a heating element has been switched on. During the process of the sequence, the tank 1 is being filled, and another warning appears for that, and another operator request, please start the cleaning process. Further alarms in this cleaning sequence are, for instance, here shown as an example, flushing of the reactor tank, a message about the temperature in the reactor inlet is too high, and at the end, the switching off of the heating element. This concrete example shows Process Event Analytics detects this chain, including the frequency, and provides therefore the possibility to optimize this chain, which would lead to the reduction of workload of the operators. Typical measures for kind of optimizing is then using PCS7 functionalities and also silencing alarms, which are really not necessary. In summary, if you're looking back to Process Event Analytics, it provides you 4 key essential things. At first, it provides you the transparency of what the plans, based on international norms and standards. It also enables you for performance decisions based on on informations gathered together. It provides you an easy implementation with no additional training. As we have seen, recommendations and informations are given throughout the entire application. And all of this is fully driven and automated by automated data analytics, providing you a less effort and quick mobilization of this application. With this provided transparency and guided by our digital assistant, you'll be able to realize performance improvements in your plant. By performing the continuous monitoring according to that life cycle and by using process event analytics, you are able to ensure the system state of your system, the quality and availability over the entire life cycle. With this short presentation and a kind of summary